some of the problems that they give you on the homework will pop this up. This is called an instructor note to remind you what the composition of the deck of cards is. It may also show up on your quiz, and you may also see it show up on a test. If you skip this problem and come back to it, if I close this window and go to the previous one, there's the same remark. If I close it, and now I go back to this next problem, notice it didn't pop up the instructor question again. But you can always find out whether there is an instructor tip if it was attached to that problem, because it's in the pull-down menu up there. But this problem that's back here didn't have an instructor tip to it. So one of the problems the instructor forgot to put a tip on the exercise, but at the beginning of your test paper, it tells us there. If you run into a problem like that, you just may have to go back to a previous problem or play hide and go seek and put out there. So here's a pretty standard type of problem. A standard 52 card deck has 4 13-card suits, hearts, diamonds, clubs, spades. They're actually telling you what was in that pull down this time. Diamonds and hearts are red, clubs and spades are black, 13 cards numbered 2 through 10, jack, queen, king, and ace. An experiment consists of drawing 1 card from a standard deck of cards. Determine the probability of choosing a black ace of diamonds. Is there a black ace of diamonds? And this is one of the few times when your probability is 0. Okay, so the author likes card problems, and we're going to have to understand some things about card problems out there. Town council has 12 members, 5 Democrats, 7 Republicans. If the president and vice president are randomly selected, determine the probability they're both Democrats. Simple event or compound event? What are you selecting? President. What's that 3-letter word that's in between president and vice president? And. President and vice president. An and statement always indicates a multiplication problem when you have multiple events. So first event, how many satisfactory people? Any of 5. How many total possible people? So the numerator are the things that meet your need. The denominator are things that are possible, whether you like them or not. 5 out of 12 people satisfy or could be elected as president. And now how many could be elected as vice president? 4 out of 11 people. And if they want a fraction, can we get the calculator to do that for us? I like groupings. 5 times 4 and group of 12 times 11. If they want a fraction, I put too many 11s on there, so with that. I did 2 times 11. So let's try 12 times 11, okay? Again, this setup right here might be beneficial because if you typed into the calculator wrong, I know what you intended, but I know why your answer was right. So that's one of the few places you get partial credit is you have a typo mistake in the problem. And if I want that to be expressed as a fraction, then I just tack onto the end of it, math 1. And it tells me that this is 5 out of 33. And I know whether they want a fraction or a decimal immediately because they tell me what they want in the problem. If I didn't want a decimal, if I didn't want a fraction, then I just would have taken that convert to fraction off the end of the problem, and I would have had a decimal that might have been to 3 decimal places. This would have been approximately a 0.152 if I wanted 3 decimal places. If I wanted 6 decimal places, then I got to count out and figure out where the round off is. These are not difficult problems. They're just counting problems. Probability of opening a lock that has 5 wheels on it, where the wheels each use the digits 0 through 9. If you know that no number was used more than one time. Simple event, compound event. Compound, because you have to dial in how many letters or numbers? 5. So there's digit 1, digit 2, digit 3, digit 4, digit 5. How many possible letters or numbers, excuse me?
2.
For the first digit of the code? 10. 0 through 9? 10. Excuse me, down here. How many of those are correct? See, here's the key of the problem. You want to open the lock. So hidden behind the scenes are, there's only one correct combination. And since there's only one correct combination, there is only one correct first number out of the 10 that you might select from. And now, how many for the second number? Only one correct out of the possible 9 remaining, because you know that no number was used more than once. And then 1 out of 8, and then 1 out of 7, and then 1 out of 6. This might be asked for as a decimal, but do you think this is also going to end up giving us a scientific notation number? Because look, your denominator is going to get huge, right? The last one, we only had 51 and 52, and it kicked it as a scientific notation. There's a good chance that this could happen as well. So maybe we know by looking at this that we go to the fraction format immediately. I'll do the hard part for you. 1 times 1 times 1 times 1 is 1. And now you figure out what the denominator is.
30,240.
And I pretty much guarantee you that if you take 1 divided by 30240, then it's going to give you a scientific notation number. Which means this tells you to move the decimal point 5 places. One place will gobble up that first digit. So how many extra zeros do you have to annex? 4 zeros. 1, 2, 3, 4, 3, 3, 0, 6, yada, yada, yada. And if they only want you to keep 6 decimal places, wouldn't this be where you crack it? So your decimal value, if they wanted 3 decimal places, might look like this. Sometimes they'll ask for decimals, sometimes they'll ask for fractions. All of these problems can be done with this standard fill in the blank thing. We're still going to count. We got card problems, we got dice problems, we got all kinds of other things that are sitting out there. So there's a start to our probability type questions. And this takes us up pretty well through the exercise sets. And we'll finish off on Wednesday, taking care of the rest of them.